Exponential laws. In the last few lectures, we were learning different loss functions which are used in binary classification. What did we learn? We learned about many loss functions like binary cross entropy, hinge loss, etc. This time, we are going to look into exponential loss. Let us see how is this loss function helping in doing binary classification. One thing to point out here, this is the loss function that is used in Adaboost. When we go to those lectures, we'll explain how it is used there. For now, we'll see how is exponential loss working. How is the loss function working? What is the logic behind? Okay. Let us start with exponential loss. First thing, we already said it is used in binary classification. I'll make the terminology clear in order to start this lecture. Then we'll go into the loss function. Coming to terminology, we'll use very similar to whatever we have already used in the previous lectures. First thing, y. Y element of minus 1 to 1. Not minus 1 to 1, minus 1 and 1. So what is this y? Y is your true label. Whatever is the true label, that is what you call as y. True label means you have two classes. One is minus 1, other is plus 1. Whichever does this particular example belongs to, that is what is y for this particular example. It can take only two values, minus 1 and 1. Next thing is x. X is your input. Whatever is the input provided, that is x. For each input x, you have to see whether it belongs to class minus 1 or class 1. This is the task. Next thing is, when your x is passed through the model, you have a machine learning model built. Through this model, when you are passing, whatever comes out of the model, the raw score that is coming out from the model, this you will call as f of x. So what is your f of x? F of x, this is the model score. I'll call it model score. So this is the value that is coming out of the model. This would not directly be minus 1 or plus 1. Using the score, you have to determine whether this particular input belongs to class minus 1 or class plus 1. Whatever is your final decision, let us call that as y cap. So what will be y cap? Y cap should be minus 1 or 1, but how is it decided? It is decided according to the sign of f of x. So I'll write it as sign of f of x. What does this mean? If your f of x is positive, you will say the model this particular example belongs to class plus 1. If it is negative value, you will say this particular example belongs to class minus 1. This is how you are going to determine which is the class this particular example belongs to. Okay, till this point it is clear. We are going to next see about margin. Margin is a term we already explained in the last lecture. We used it in hinge laws. It is y into f of x. What is the importance of this particular margin? Whenever your margin m, if it is large and positive value, what does it mean? Whenever your margin is positive, it is a correct classification. Whenever your margin is negative, it is a wrong classification. How is it? Because if your y is plus 1, let us say true label is plus 1, then ideally your f of x should be positive because you are deciding the label using sign of f of x. If f of x is positive, that means if true label is plus 1, then f of x positive means classification is right. So if plus 1 into a positive value will give you positive value, which means classification is right. Let us say true label is minus 1. Then ideally your f of x should be a negative value, which means sign of f of x will be minus 1. That is the actual class that is required here. That means minus 1 should go with negative value of f of x. That will again give you a positive value of margin. This value m will be positive because it is y into f of x. What I meant to say is, whenever your value margin m, whenever it is large and positive, That means you are confidently having a correct prediction. It is a correct prediction and it is confident, a very good correct prediction. Next case is, what if it is positive but not large value? If it is just a positive value but a small positive value, that means your classification is right because your model said f of x is a positive value. So y cap will be the right classification is right. Not just f of x is a positive value. If y into f of x, this value is positive. That means if f of x is positive, y is also positive. If y is negative, f of x is also negative. Both those cases, your classification is right. So if m is positive but not a large value, then still your classification is right. And the third case, what if your margin is negative? If the value of m is negative, that means your classification is wrong. It is a misclassification. This is the logic behind usage of this term called margin. Okay. What is your goal now? Your goal is to maximize margin because whatever be the largest margin possible, if you can create that, that is good for you. Your predictions will be confidently right. This is the logic you want to use in exponential loss. Let us write the loss function and understand. My loss function will look like this. Loss function of y and f of x. These are the two terms that are required. How will my loss function be? I'm calling it exponential loss. So you can already kind of guess what it is going to be. I'm calling it exponential loss. So it is going to be e power minus y into f of x. You may think, what is the importance of this minus? That we'll explain right now. E power minus y into f of x. This is what is your loss function. It can also be written as e power minus m because your m is y into f of x, right? Next thing we are going to discuss is, how is this a good loss function? How is it going to ideally provide you with the ideal loss that is required for training? This is what we are going to discuss next. Let us consider that in this particular example, your actual value of y, that is yi, let us consider this is plus 1. You have an example which is input is xi. This xi belongs to class plus 1. This is the scenario. Now let us understand, how is this particular loss function helping you to write the right loss value? Okay, there can be two cases now. First case is that your f of xi, whatever your model gave, this particular value is large and positive. If this is the case, then what will be the value of margin, that is yi into f of xi? The value yi into f of xi, this value will also be large and positive because your yi is plus 1, we already discussed, and f of xi is large and positive, which means yi into f of xi, this should also be large and positive. If this is the case, then what will be the scenario of e power minus y into f of x or yi into f of xi? What will be the value of this particular thing? For that, you need to first understand how the graph of e power minus x looks. E power minus yi into f of xi. How does it look? If you understand that, understanding this whole thing is very easy. The reason I am trying to explain through graphs is, when it is illustrated, it's much easier. When you see the graph, it's easier for you to understand, okay, this is the value of this particular e of x. Okay, I'll plot a graph here. I'm going to plot the graph of e power minus x. Okay, so my graph will look something like this. This is my graph. Here I'll have my loss. On this axis, x-axis, I'll have y into f of x. Y into f of x is my margin. How should my graph look like? My graph will look like something like this. My graph will be, this is same as the graph of e power minus x. Okay, it will come from here, and as the value goes positive, it will be like this. This will be the graph. So the values, I'll just put the values here. This is the graph of e power minus y into f of x. Y into f of x is the value in the x-axis, In y-axis, I have loss. Then the graph of e power minus y into f of x will look like this. This is 0. Then 1, 2, 3 will be over here. Okay, this is the scenario. Here you have negative values, negative 1, negative 2, so on. This is the graph. Looking at the graph, try to find out what will be this value, this particular value in this scenario. That is why I drew the graph, so that you can see the graph and understand. Y is positive, f of xi is large and negative, which means my yi into f of xi is a very large value, right? Yi into f of xi is a very large value. If my yi into f of xi is a large value, then what will be e power minus yi into f of xi? I'm saying yi into f of xi, this thing, x-axis, you have a very large value. So you are somewhere over here, okay? It's in a very large value in x-axis. Then my e power minus x graph, that is here, e power minus y into f of x, that graph says the value will be very small here. That means my loss will be very small. Is this right or wrong? Whenever my yi into f of xi is very large and positive, that means I have a right prediction, I have a confident prediction, I should have very less loss for this particular example. Rightly, when I used e power minus yi into f of xi, my loss is very less in this particular scenario. So I am trying to tell you why this is a good loss function, okay? Let us try to see the second case. Again, my yi will take the same value plus 1. That is, this particular example belongs to class plus 1. In case my value of f of xi, if this is negative, what does that mean? If my f of xi is negative, the value yi into f of xi, this is also going to be negative because my yi is plus 1. So that into a negative value is again going to be negative. What does that mean? Whenever yi into f of xi is negative, in this graph, the value will be somewhere over here, anywhere over these places, because it is negative. My yi into f of xi is negative, so it should be somewhere over here. That means the value of e power minus y into f of x is a large value because it is going up like this. It is going to be a very large value. That means whenever I made a wrong classification, a misclassification, the value of loss is very high. From this, what did you understand? Whenever your classification is correct and confident, the value of loss is very less. Whenever your classification is wrong, that is whenever it is a misclassification, your loss is very large. This means e power minus y into f of x, this is a very good loss function. Whenever you actually need a larger loss, it is depicting a larger loss. Whenever you actually need a lower loss, it is depicting a lower loss value. So this is how you should understand that exponential loss is actually helping you as a loss function. It is a good loss function to have. So another way, if you simply put numerically and see this, let us say your value y into f of x, if this particular value, let us say it is something large and positive, something like 4, 5, something like this, then it will be e power minus 4, e power minus 5, something like that. That means e power minus x, when x is 4, that will be a very small value. So this will be very small value, okay? Next thing, let us say it is 0.1. Y into f of x, if it is 0.1, that means it is correct classification but not confident enough. So the value is somewhere over here, which is comparatively a larger value of loss. So this particular point, you have a larger loss compared to what you have at this point, right? If it is negative, if it is -1 or something, then you have an even larger loss. This is the logic. Next thing you want to understand, because we are discussing about a loss function, you should just see the gradient as well. So whenever you are a machine learning student, you are learning about loss function, it is important that you understand gradient, because gradient always comes into calculation whenever you want gradient descent or something. First thing, your loss function is e power minus y into f of x. This is your loss function. What should be the gradient then? Let us try to find out gradient. Gradient is dl by df of x. This is what you call as gradient. First derivative with respect to f of x. That is what you're calling as gradient. Then what will it be? E power x. Whenever you take derivative of e power x, that will be e power x itself. So this will be e power minus y into f of x. I'm taking derivative. Okay, let me write like this. D by df of x of this value, right? Of e power minus y into f of x. What will this value be? This will take the value e power minus y into f of x into, I have to take derivative of this value, right? It will be d by df of x of this particular value minus y into f of x. And what is this particular thing? D by df of x of minus y into f of x will be minus y. So here I can write into minus y. If I take this y forward, this will be minus y into e power minus y into f of x. I can do one more thing here. This particular thing is same as this loss. So I can substitute L here. That is equal to minus y into loss. This is the gradient. So if you take gradient of this loss, you are going to get minus y into loss. This is what you have to understand. So from this you can automatically understand that when this is having a very large value, your gradient is also having a larger magnitude. The magnitude of this gradient, it will also be large. That is, value will be small, magnitude will be large. So whenever, what you want is, whenever your loss is larger, you want a larger gradient. So whenever you have a large loss here, because of this loss, your gradient is going to have a larger magnitude, which means whenever you are training the model, you have a model, you are training, you use the gradient in order to update your parameters. Whenever your loss is large here, because loss is directly there in the gradient, it is easy for me to explain that because loss is large, this value, magnitude of this value is going to be large. The gradient is going to be large. If gradient is large, what happens? The model updations will be larger. That is, your hyperparameters of the model are going to be updated by a larger value. It is going to be taking a larger step. Why is this right? Because you had a loss. That is, you had a larger error. Model needs larger correction. That is why gradient is large. You are taking a larger step towards correcting the value of your parameter theta, right? The parameter theta that you're having, you're correcting it to a larger level. But what if your y into f of x is small or negative, let us say, then you want a, that is the case what we discussed. If it is negative, it is error case. If it is positive, what happens? If it is positive, then you want a lower gradient, right? So that is what this particular gradient is explaining to you. This is it about exponential loss. This is another loss function which is used for binary classification. From the next lecture, we'll move on to classifying with multiple classes, multi-class classification. Okay.